A while ago I bought this rotary table and I'm gonna use it for my next Hexagon project. And at the moment I've got my lathe set up, so I'm making a plug, which I haven't done before. I haven't done it yet, but I need one. I forced this dowel in the center hole. The center hole was about 5.5 millimeters. This dowel was 6 millimeters, but I measured it and it is 5.55 millimeters at the moment. So I will make something which fits in here and which also has a center drill hole on which I can align my micromill. So this surface here also looks ground to a specific size, 14 millimeters. Yeah, I'm also gonna try to incorporate that dimension in the plug. Started roughing on a piece of stainless steel. I'm gonna turn this down to 5.55 millimeters and another step to 14 millimeters, and then I will leave this at the current diameter and cut up the stock, reverse it, clock it in my forge hole, and then center drill the other side with a small center drill, so I can also put that center drill in a collet in my micromill, and then dial in the center for the rotary table. So I shifted the piece in the jaws a bit more towards the jaws, and I finished the roughing. I've got about a millimeter to go here and half a millimeter here. I'm gonna let the piece cool and do the final turning when it's a bit colder to make sure it's a very snug fit. Got a very nice fit. Now I will cut the piece of size. I won't do it with a parting tool. Takes too much time to do it properly on my lathe. So I think I'll just use an angle grinder, and I have to reverse it anyway, so I will clean it out later. I added this step to make it easier to fit the part. Maybe you've seen I've also got a quick change tool holder, but I still sometimes use this one. Well, I use it quite often. That's because of this boss, and this tool block wasn't designed for this machine. There's a hole for the boss in this tool block, but there isn't one in here, so I have to fix it. At the moment I use a adapter plate, but I think it's a bit too thick, and I have to reduce the height a bit. Because if I fit it like this, it's too high, and some of the tool blocks have to drop below the line, below the tool block, and that's not possible at the moment. So I either have to cut some openings in here, or reduce the height, but it needs some work, and I don't want to do it yet. I want to service the machine first to reduce as much play as possible to really make this a proper part with parallel sides. I've already fitted the sleeve over this bolt. These holes didn't match up. This one was a bit smaller, so I had to bore out the 4-way tool block. Here you can see the problem. This block won't go any lower, and the bottom of this top cylindrical part is center height, and as you can see I still need to drop a few millimeters, and I just don't have the room for it, so I either need to make this spacer thinner, or turn an opening for the boss on this bolt in the block itself, but I don't really like that option, but maybe I have to. I won't address this problem now, I will just continue with the hexagons. Faced some hexagonal stock, and I'm gonna center drill it. I measured the tip of the center drill, and I'm selecting a drill which is just a tiny bit thicker, and drill the hole. And these are rather cheap drills, and they're not very good, but I just need a hole which is tiny bit bigger than the tip of the center drill. I parted off a small disc, and it's kind of a weird pattern on the back side. I think it's got something to do with chatter, but it's not a problem. I clocked in the part. It's within hundredths of a millimeter, but I noticed there is some play when I do this, and that's not a good sign. Maybe it's got something to do with the bearings. I hope it doesn't, but these lathes are kind of cheap, and they are built to cheap specifications, so maybe there's some room for improvement, but I have to check it. But I was already planning to do some servicing on the machine, so I will have a chance to look at it then. Now I will face this and put a tiny center drill hole in it. I had to grip the part by the smallest side. This surface is not particularly good. I didn't clean this up, and there's some dinks in it. So I had to clock the piece out on this side, on this step. This is not a nice cut. I'll have to carefully clean it, and then I will put a tiny center drill mark in the piece, and then it will be finished. I center drilled the piece. I also cleaned up this and this edge. And now I will use a 1.2 millimeter drill to drill out the smallest part of the hole the center drill made. Here's the finished plug. The center drilled hole. I have to twist the plug in. It feels tight. Secured. And now I can fit the rotary table on my micromill, and dial in the center as 0. This rotary table is the tilting type. It's Soba. I think it's a known brand of imported machine tools. Not very high quality. When I bought this, I think 1.5 or 2 years ago, it was on discount, and it still is, so it's an indicator for quality. These two holes were not aligned properly when I bought this. There were both just round holes, but I had to mill out this one, because if I would put it on my milling table, then it would be at a slight angle, and then you can do anything with measurements of angles and displacements. So that was a problem, that's why I milled it out. Now I can indicate this side, so it will be more accurate if I want to use tilting action. Well, there's not a problem with this. This is my micromill, and this is the highest setting, or I can't rise it any further. And I still want to add a milling clamp type of thing, which is on its own locator plate, which I made. So I also have this riser for the spindle, and it goes between this aluminum part and the base, so I have a bit more clearance. So I have to bolt it in now. I've added a spacer between the column and the base, but I noticed there is a bit of play in it. If I can get my indicator. See, there is moment. It's not very much. 410, 400. I mean, but in the meantime, I've also been to the metal supplier, and I found this this steel part. I think I'm gonna try replacing the aluminum block and see if it has any positive effects. And maybe I can make spacers for in between the two sides, which will make it even more rigid. And if that doesn't work, I can also get a solid block of steel or something like that and try that. There is a set screw here, which can adjust the height for the table, so you can zero it, and that's the first thing I have to do. I don't think I can indicate it here and still access the hole on the bottom, so I have to put it at an angle, indicate it to 0, then align this part, get it to 0 in reference to the spindle, and then I can think about mounting this vise. Another problem I encountered is this hole is tapered. So it fits a screw like this, but now I've milled the slot, and if I use the same type of screw, then tightening the screw will put twisting force on the base. So I had to find a screw with a flat head and cut it to size to make it even fit, to make it also fit the T-slot. So that's another thing I had to do. So this was the next problem. The head of the screw wasn't centered on the threads properly. It was misaligned, and I turned down the edge a bit to make it round, so it wouldn't hit the sides of this slot. With a parallel on the rotary table, I will travel along the length. The machine isn't very and the machine isn't fixed to my desk, so I slip around a lot. And I tightened the grip quite hard, so there's quite some force. I didn't want any play in the grips. I'm halfway now, and it's about 0.06 millimeters off. It's tilted up, so I need to lower the set screw. The set screw is tightened by another set screw. Well, one is a leveling screw, I think you'd call it, but it looks a bit like a set screw. Hope I have the right size. Yes. Loosen this. Releasing the lock. Out of trouble. Fixing this. Securing it here. And see what that did. So now it's getting a bit lower, so I should raise this end a bit. but thinking the dial should keep the same value if I adjust it from here to here, because the pivot is here. So the actual offset changes differently. Now I will just return it to the beginning. So I'm off by a bit more than 0.02 millimeters. Now I'll just repeat this process till I'm satisfied. And I think I'll stop when I'm within 1/100th over the whole length of this parallel. So that didn't take too long. I had to traverse it 2 or 3 times. So that's done. It's within 100ths now. Next thing is indicating the rotary table on the milling table. And this is not a ground edge, it's painted over. And I know it's not in line with this edge. So I can use a square to align it a bit, and I know what kind of gap I should be looking for here, but the rest I should do with the indicator. So I indicated the rotary table. I'm satisfied with it. It's not perfect, but if it would be perfect, then I couldn't afford this machine. So it's okay for now. Now I have to align the spindle to the center of the rotary table, and that's where the plug comes in. The center hole should be the exact center of the rotary table. Now usually you would indicate this with the indicator attached to the spindle, and then sweep it around. And then you can zero in using the X and the Y. But I don't have anything to hold my indicator to the spindle. I may have to make something myself, which I can do if I have a functioning rotary table. But for now I thought about using the center drill I drilled the hole with, but there was still a bit of room left for wiggle, so I checked my set of broken PCB drills, which I always keep. You never know when you can reuse some material, especially drills or center drills, mills, and these are, I think, type of carbide drills. But this chamfered part is a nice fit in this hole. I already tried it, and I will try to get it in here without getting any wiggle, and as deep as I can. have a problem with my spindle and my collets. The collets won't close very good. They stick out of the collet holder, and when I tighten it too much, they grip it, and they're hard to get out of the holder. I'm not gonna force it right now. I'm kind of at a weird angle because of the camera tripod. But I can align this, and I think I can get it a bit closer to the center. And then I have the center of the rotary table. And then I have to fit this toolmakers clamp, which is not self-centering. So I have to align this on here, and if I want to make something like hexagons for my hexagon series, then I also have to align the hexagon with a center on the rotary table. So I think this is a good fit. I don't know if it's likely to happen, but this is the deepest I can put the drill, and it doesn't grip when I turn the rotary table. So I think this is okay. Right, I'm hoping I can use a trick for aligning this. Just get some self-centering action because of the two catching chamfers, one on the inside, one on the outside. But I can't tighten it now. I need a fence over here to be able to rotate the hexagon 6 times. To make nice patterns. Of course I can do it with the rotary table by the divisions with the angles. But I also want to do it like this. I found this piece I was looking for. I can clamp the workpiece up against it, and then undo it, rotate it, and clamp it again, and it will be fairly accurate. So that's it. I think I now have a good way to hold these workpieces on this rotary table. Only one thing I can do now is indicate it like on this surface, and then use the rotary table to zero it in this direction. And then won't be able to do. Now I can obviously do pieces of angles, but radii. But I'd have to work with tenths of degrees, so that's not. It's doable, but it's not an easy thing I want to do with my first try. So I'm gonna use this corn cob mill now. It's a Chinese one. So, time for some action. I've put in a piece of a little over 5 millimeters. I'm not sure about this, but I think I have to rotate clockwise. And the finish on this is actually quite nice. It's a very nice pattern. Not sure why it looks like these are spirals. This is faced on the lathe, this side. I had some safety goggles on my camera, kind of affected the color. This side is faced on the lathe. And this on the rotary table. This pattern is not quite what I expected. I expected concentric circles. At least. Yeah, maybe it's just an optical illusion. Well, I think it's an optical illusion, but I think it is a very nice effect. And I kind of had different plans for this 5mm one. So I will put this aside and I will do another one. But not right now at the moment, I have to take a break.